In this last section, section 2.6, we will be applying what we've learned in this chapter about energy to what you already know about nutrition. So first of all, you may wonder, how in the world did they ever figure out how many calories were in like your apple or your banana or your nuts or whatever? They have a process called a calorimeter that you've got this container that's insulated. There's water that is here, and they put the particular food item in there, and they have a way to burn it. Then, of course, there's a mathematical formula to actually calculate. Once you figure out the change in temperature of the water, they can then calculate how much energy by using the mass and the change in temperature of water. We're not going to worry about that formula. We do use that formula in general chemistry. But that's how they actually calculate how many calories are in food. All right. So, let's make sure and reiterate what we've already mentioned in an earlier section about calories with a capital C, calories with a little c, kilocalories, joules, and kilojoules. So here we go. Since 1 kilocalorie is 1,000 calories with a little c, and 1 calorie with a big C is 1,000 calories with the little c, then we know that 1 calorie with a big C equals 1 kilocalorie. And if we look at this table here, that it's a table that I know you've used before, and you've seen before that not exactly maybe this table, but for example, if you look at the food type, carbohydrates, you know that it is 4 kilocalories per gram, or 4 big calories per gram. And fat, is like twice as much. It's 9 kilocalories per gram, or 9 big calorie per gram. And protein is the same amount of calories per gram as carbohydrate. And of course, when I said that, I meant kilocalorie or big C calorie. All right, as we're on this page, we can look at some different amounts of carbohydrates, fats, and proteins for some of our different foods, and the amount of energy in both kilojoules and kilocalories, i.e. calorie with a big C. And of course, you know that the amount of energy that I need is different than the amount of energy you need, that it depends on the age and the gender and how much running around you're doing. So let's look and see for a problem here. Let's see if we can calculate how many kilocalories, i.e. big C calories, does a cup of milk contain. I'm sure you've done a problem like this in some of your other classes, especially probably a nutrition class. But this is where we use dimensional analysis again. Wow, different section, but we are still using dimensional analysis, which we learned a while back. So we can convert from 13 grams of carbohydrate, we can convert from 9 grams of fat, and convert from 9 grams of protein by using those values back in the chart, right back here at this chart right here. So let's come back to this problem now. Okay, so pause it, see if you can do it. All right, so we have 13 grams of carbohydrates. We know the conversion is 4 kilocalories per gram by looking at that chart. So when we do the math, that's 52 kilocalories. 9 grams of fat times the conversion factor is 9 kilocalories per gram, is 81 kilocalories. 9 grams of protein times 4, and again we get all these values from that chart, 4 kilocalories per gram, which is 36 kilocalories, which is 169 kilocalories. We can round to 170 kilocalories, which is the same as 170 big C calories. So the answer back there is C.